So let us proceed to solve these two equations. How do you solve? Put the value from 2 in 1. Putting x is equal to root 3y from 4 in 1. From 4 in 1. We get root 3y. You have x plus y is equal to 15, right? So x is equal to root 3y plus y is equal to 15. Okay. I got the right equation. Yes, x is equal to root 3y. Yes. So that means I take y common. I get 1 plus root 3 is equal to 15. That means y is 15 by root 3 plus 1. Okay. So let us find it in terms of after rationalizing the denominator. We have 15 root 3 minus 1 divided by root 3 plus 1 into root 3 minus 1, rationalizing the denominator. That means you get 15 times root 3 minus 1 divided by 3 minus 1. And 15 times root 3 minus 1 by 2. That's the value of your y. But do we need to find y? We need to find out the height, right? We need to find out the height. So once you have found out y, now you can find out the height, because you need to find out x. You have found out the value of y as 15 times root 3 minus 1 by 2. So therefore, what is h? Hence, h is equal to, hence from 2, this is equation number 2, right? Yes, hence from 2, h is equal to root 3y. That means root 3 times y is 15 times root 3 minus 1 divided by 2. Okay, which is equal to, now you can simplify and find out. How will you simplify? You have a 15, you multiply this root 3 with this root 3, you get a 3. And then again you multiply this root 3 with this minus 1, you get a minus root 3 divided by 2. Now you can just put the value of root 3, 3 minus 1.732 divided by 2. So 3 minus 1.732 will give you 1.15 into 1.268 divided by 2. So multiply this by 15, you get 19.02 divided by 2. So this is 9.51 meters. Okay. So here I have found out the value of x. Okay. In fact, here h is equal to x. That's why. Okay. You could have directly written instead of doing all this. H is equal to, you could have directly, we could have, if we could have found out x, then we could have found out from this only. H is equal to x. But since we found out y here first, that is why
এই
we used
এই এই
equation
প্রীতি
number 2.
বাঞ্ছনা
Okay. That's why.
এই প্রীতি বাঞ্ছনা
Okay, just because we found out y, that's why you put it in h is equal to root 3y. Otherwise, if we would have found out x, we would have put it in equation number 3. That's it. Let us now move on to the exercise problems. So the first exercise problem that we're going to do is this: a vertical tower 20 meters high is 20 meters high. A man standing at some distance from the tower knows that the cosine of the angle of elevation of the top of the tower is 0.53. What do you mean by cosine of the angle of elevation? Cosine of the angle of elevation means cos of the angle of elevation. That's simply, they have simply given their full form here. Instead of cos, they are writing cosine. Okay. Cosine of the angle of elevation of the top of the tower is 0.53. How far is it standing from the foot of the tower? So let us draw the diagram. You'll have marks for drawing the diagram also. Let us try to understand how the diagram is drawn. Let us say a vertical tower is here, which is 20 meters high. Okay, a man standing at some distance from the tower knows that the cosine of the angle of elevation on the top of the tower is 0.53. This is the base of the tower, that means. Right? And there's a man standing here. Okay, there's a man standing here at some distance. He is observing the top of the tower. He's observing the top of the tower. And this angle of elevation here with the horizontal, this is your horizontal. Okay, this angle of elevation here, let us say this is theta. Okay, this is the line, the hypotenuse is the line of sight. So A, B, this is 90 degree. C, this is your tower. Okay, so cosine of the angle of elevation is 0.53. That means here cos theta is equal to 0.53. Okay, where theta is the angle of elevation. Theta is the angle of elevation of the top of the tower. Theta is the angle of elevation of the top of the tower. Okay, so cos theta is given to be 0.53. Now, once you have done, I have already discussed trigonometric tables with you. Now, once the value of cos is given to you, you can find out the actual angle, the angle that we're talking about. So let's see 0.53 refers to which value of cos. How do you look up the tables? You have here, this is your cosine table. What is the value of cos here? The value of cos here is 0.53. So let's look up cos table and locate a value that is very close to 0.53. If we get the exact value, no problem. That will directly give us our angle. So if you see in the tables, see the closest value that I'm getting is 0.5299. 0.5299. This is the closest value I'm getting. You can approximate this to 0.53, right? And if you see the value of the angle here, how much is the angle here? It is 58 degree. Okay. So coming back to the sum, that means therefore cos theta is equal to 0.53, means theta is equal to 58 degrees. So we have found out the angle. Now once we have found out the angle, the question here is how far is the observer standing from the tower? This is the position of the observer. This is the position of the observer. How far is he standing? That means you have to find out BC. Okay. So again we have the length of the tower here as your perpendicular. This as your base. Okay. And this as your angle here. They are related by tan. So therefore we use tan. Tan theta is equal to AB by BC. So tan 58 is equal to AB 20 and by BC. Now let us look at the tables once again. Why look at the tables? Because we have to find out the value of tan 58. How much is tan 58? Let us look at the tables. Tan 58. Tan 58. This value here. 1.6003. Let me just put the value here now. 1.6003 is equal to 20 by BC. That means BC is 20 by 1.6003. Now you can shift the decimal to the right. You will get 4 more zeros. Okay, this is what you are getting. Now there's no other option but to divide. You will have to go back to your class 3-4 knowledge of division. I've shown you here the division. Okay. You have to, you just have to divide this. Okay. And get 12.9.
Sir,
Yes, tell me.
so after the point 1.6003, we have to write all the 4 digits after the point.
What is the alternative? Tell me what is the alternative? I mean, is there any other way? If not, if you are not
So
writing,
we cannot write only 1.600.
yes, you can. You can. I've taken the exact value. You can approximate it to 1.6, and you can take. So you will not actually. In that case, you may get 12.5 or something. Okay. Let us move on to the next problem. Number 2. In this figure, the angle of elevation from a point P on the top of the tower QR 50 meters high is 60 degree, and that of the tower PT from a point Q is 30 degree. Find the height of the tower PT correct to the nearest meter. Okay, so let's see here. The angle of elevation from a point P on the top of the tower QR. Okay, fine. Let us first draw the tower QR. This is the tower QR. Okay, from a point P from the top of the tower QR. So that means this tower is QR, and this is your top of the tower, and there is an observer observing the top of the tower from, say, here. Okay, say a point P. So see the question here, the angle of elevation from a point P of the top of the tower QR. So if you join this becomes your line of sight From P, the observer is observing the top of the tower. This is your line of sight, right? And this becomes your horizontal. Okay. The angle of elevation here is given to be 60 degree. So this is 60 degree. Okay. And this height of the tower QR is 50 meters. Okay. 50 meters high, 60 degree, and that of the tower PT from a point Q. So here again, now the observer comes here at the point Q. He starts observing at the top of another tower, tower PT. So let us draw a tower PT here. Okay. And see that the angle here is lesser, 30 degree. That means this tower is shorter. Okay. That is why I drew a short tower. See that the angle of elevation from this observer at Q is given to be 30 degree. That is why this tower is the shorter tower. Okay. So that's why that you will have to, if you use your in your examination when you're drawing, if you use your protractor, okay, then it will be very helpful. Okay. So this is P, tower PT. Question is, find the height of the tower PT correct to the nearest meter. You have to find out this height. Okay. Let's see how to find out. First of all, observe this triangle, the bigger triangle, bigger right angle triangle. This one, PQR. See that the angle here is 60 degree. Okay. And just opposite this, QR is your perpendicular, PQ is your base, right? So therefore, if you use tan 60, so if you use tan 60 here, divided by PQ, this QR divided by PQ. Tan 60 here is root 3 and QR here is 50, and we need to find out PQ. That means PQ is 50 by root 3. That means 50 root 3 divided by root 3 into root 3. We have rationalized the denominator. So simply 50 root 3 by 3. Fine. We have found out PQ. But the question here is you need to find out the length of this tower PT. Now that means now we look at this right angle triangle. Now we look at this right angle triangle. We write in triangle PQT. Again, you see that there's an angle 30 degree here. So therefore tan 30 is equal to PT perpendicular divided by base PQ. That means tan 30 is 1 by root 3. We need to find PT. So write PT as it is. PQ we have already calculated. So you can put the value of PQ. Let's put the value of PQ as 50 by root 3 only. We don't need the rationalized part here. 50 by root 3. And therefore we get 1 by root 3 is equal to PT root 3 divided by 50. Okay. That means thrice PT is equal to 50. If you cross multiply, that means PT is 50 by root 3. And because we need to find out PT, have they asked you? Yes, find to the correct nearest meter. So let's rationalize the denominator. Multiply above and below by root 3. So you get 50 root 3 by 3. So this is 50 into 1.732 divided by 3. Okay. So now you can multiply this. So I've got 50 by 3, not 50 by root 3. Mistake, sorry. So straight away. So it's 50 by 3. Simply it is 16.66 meters, which is equal to 17 meters, because you need the answer correct to the nearest meter. So that's it. The next problem is an interesting one. Let's try to understand the problem first. An aeroplane, when flying at a height 3,125 meters from the ground, passes vertically below another plane at an instant when the angles of elevation of the two planes from the same point on the ground are 30 degree and 60 degree. Okay, a little complicated to understand maybe, okay, but nevertheless not too difficult. An aeroplane, when flying at a height of 3125 meters, say you have an aeroplane, this is your height, this is your ground level. Okay, you can extend it here also, no problem. This is your ground level, and here you have an aeroplane flying, okay, at a height of 3125 meters. So this height here is 3125 meters. Okay, from the ground passes vertically below another plane. Okay, so this is vertically below another plane. Okay, so this plane, there's another plane here, it is passing just below the plane on top, which is at a height of 300,125 meters. When the angle of elevation of the two planes from same point on the ground, suppose angle of elevation means an observer is here. Okay, you have the observer here. He's standing and observing the two planes at a certain instant. Okay, because see, the planes are moving. It is not possible that planes will be aligned in this manner. Okay, I mean, even if they will be aligned only for a fraction of a second. So that is why this, you see, this word instant is given. At an instant, at in the fraction of a second, the observer captures this angle of elevation. Okay, so what he does is he captures this angle of elevation. This is the line of sight, and this is another line of sight. He captures this angle of elevation to be this angle and this angle. He captures this angle to be 60 degree angle of elevation and this angle to be 30 degree. You need to find out the distance between the two planes at the instant. What is the distance between the two planes? This is the distance between the two planes. So at that particular instant, you need to find out the distance between these two planes. Okay, so it's not a very difficult job finding out, because you have two right angle triangles here. You have this right angle triangle, the smaller one, and you have the bigger right angle triangle. Okay, if I label this, then it will be, say, this is the position of the plane, this is the position of the second plane B, and this is your ground level, a point just below the planes. Okay, let's say this is perpendicular, and you have point D where the observer is standing. Okay, so that means you will have to find out this distance, and you have that which triangle to consider. You will consider triangle BCD. Okay, this triangle in red that I have taken, the smaller one, and you will consider the larger triangle, that is ACD. These two triangles you are going to consider, and you're going to find out the height. That is, you will find out this perpendicular with the help of tan 60, and then you are going to find out this perpendicular with the help of tan 30, and then you are going to subtract the lengths so that you will get up this length, this height in fact. Okay, so I stop here for today.